This is Vinay, and I am explaining you the second question of probability of homework 10 of probability and stochastic processes class of Professor Chen. So in this question we need to, from the notes given by Professor Chen, we need to collect the definition of properties of the stochastic processes. So here they are. Wide sense stationary process, it's a stochastic process. So this is property, sorry. So a stochastic process is called wide sense stationary process if its mean is constant and autocorrelation is a function of time difference. When the input is wide sense stationary process, the output of stable LTI system is also WSS. Second is independent increment process. So this xt is a stochastic process. So for two different moments and independent xt1 minus xt2 and xt3 minus xt4 on non-overlapping intervals t1 and t2 and t3 and t4 on non-overlapping intervals, these two differences will be independent, so then it will be called independent increment process. xt is now this is a Markov process, very famous one. So the next output will only be depend on present output, and it won't have any effect of past outputs. So like Poisson process, Poisson impulses, semi-random telegraph, random walk, and Wiener processes are all Markov processes. Now the normal process or Gaussian process, it's said to be so if the random variable xt1, xt2 and xtn are jointly normal for any t1, t2, like they are individual normal, and the joint function of all these will also be normal, which is represented by this expression. So this is a function of a normal, this is a expression of a normal function. So if that random variable fits in this joint density function of that random variable fits in this expression, it is a normal process. Fifth is a strict sense stationary process if its statistics is not affected by a shift on the time axis. So it's same at every time moment. Now the white noise, so it is some extension of Wiener process, we can say. Say Wt is a Wiener process, then its derivative Vt, such that mean of Vt, that is the mean of EW dWt by dt, taking the derivative outside of the mean function, is 0. So in this case a stochastic process Vt is said to be a white noise if its mean is 0 and RVT1T2, that is autocorrelation function, is equal to QT1 delta T1 minus T2. Now next a stochastic process xt is said to be a mean ergodic process if limit of time in constant t tends to infinity 1 upon t2t minus t2t xt dt is equal to the mean function of xt. And the last one, a stochastic process xt is said to be a martingale if it satisfies this condition ext x s. This is like a conditional expectation is equal to x1, so condition is equal to mean of condition. Thank you.